Today we're going to learn about the TypeState pattern in Rust. We will combine it with the builder pattern we created in our last video, and the goal will be to make our runtime errors compile time errors. So for example, previously, when the URL was not set in our request builder, we got a runtime error raised by our build method. But now, with the type pattern, we will learn how to make this runtime error a compile time error. And when the URL is set, then obviously, we get our request back. Then we learn how to have multiple states so that our method property behaves the same. And finally, as a bonus, we will learn how to use PhantomData when the type state does not need any data. So let's implement our first type state. First, the TypeState builder pattern is built over the consuming builder pattern. Let's do a first quick overview. We have our request object that we need to build. We have our request builder with all of the properties as options or vectors. And then, as implementation, we have our new function, which returns the default, none for options and empty for vectors. We have our property setters that mute the corresponding self properties and return the self to be chainable. So far so good. And finally, we have the build method, which has a runtime check for the URL, and then we have the default for the method property when it's not defined. So both of those, we are going to make them compile time. And then we return our request result. If we bring our main.rs file, we start with our request builder, set some values, add some more, and then call the build method. At the end, we do our pretty print. Let's bring our terminal, do our cargo run quiet, and we get our request. Now, if we comment the URL setting, everything compiles. But if we do a cargo run, we get a runtime exception because of our checks that we have in our build method. So that is okay, but it will be great if we could call build only if the URL has been set. So let's do that with our TypeState pattern. We're going to fold the build function, go to the top, fold request, and now the first things we're going to create is our state types for the URL property of the request builder. And we're going to create two types. First, a no URL type, which has no data. So we're just going to use a unit struct. And second, a URL type, which will have the URL string. So we're going to make it a tuple struct. Now, an important point here is that while it looks like we could use an enum with these two variants, we can't, because we're using types as state, so we need two different types. And an enum will be a single type, as variants are not types. So now what we want is both of these types, we want to have them implement default and clone, as they will need to fit into the request builder. Okay, so now we're going to make our request builder generic over U, and the URL property will be of type U. For that pattern, we do not really need a custom trait bound on U, so in our case, U just needs to implement default and a clone trait. Obviously, our request builder implementation breaks. Let's fix that. So for the request builder, we need to add a generic U, and we're going to keep it open for now. Now, the new function that calls the request builder defaults needs more context to know the type of U, because since it needs to create a new request builder, it has to set the value of the URL, which is of type U, which at this point we don't know. So the way to solve that is to move the new function into an implementation of the request builder for the no URL. We paste it there, and now our request builder default has all of the information to create the right request builder type. And because our no URL implements default, all is working well. Now the next one to fix is the URL method. First, the URL property is not of type option anymore, so the insert does not make sense. And actually, the URL method must return a request builder of URL. That is the whole point of the function, because it defines the URL value. So in the body, we need to return the new data matching the return type, request builder, and for the URL property, we're going to use our tuple struct type url_into to get the string. And for all of the other properties, we're going to move them into this new request builder. And now we have a request builder object with a URL property matching the return type. Some important points here. First, in Rust, when we use generics, the Rust compilers will create multiple types. This process is called monomorphization, and it does increase the binary size. But in return, it makes the code design much more powerful. So it's a trade-off that we have to make. My take so far is to not obsess too much about the impact on monomorphization on binary size, except if I am doing embedded programming. Second, all of the moves that we are doing are heavily optimized by the compiler, so they probably have known to negligible impact on the runtime. So now we have fixed our URL method. The method function is completely fine because it does not touch URL property and does not create a new request builder. And it just returns self, and same for the body, and same from header. Now on the builder side, obviously, things need to change. First, we do not want the runtime check anymore. And in fact, the type of self URL is not known in this context, as the only thing that we have is a generic of you. So the way to solve that is to take this function and then to implement our request builder for URL. And now we know the type of self URL, and so we can remove the runtime check. The methods works as before, and the request URL property will take the request builder first and only tuple value, because our URL type is a tuple struct. And so now our request URL owns the string. And that's it. Let's go back on top, bring our main file, and now we have a red line under our build. Pretty cool. And if we do our cargo run quiet, we get our compiler error saying that the build method is not defined for the type request builder no URL, which makes total sense. And if we uncomment the URL setting, press save, it compiles, and if we run it, we get our request back. So now what about adding another state? What about doing that for the method property as well? So to do that, very similar, in our state, we are going to duplicate the URL states and rename to method. And then in our struct, we add the m generic and make method property of type m. Now our new function will be for no URL and no methods, and everything works because all of our types implement the default trait. For our build implementation, we are going to require method. Now we can remove the default logic and make our request method take the value from our request builder method tuple struct. And then for our commands method, we are going to add m generic because we want to work it both ways. And for the URL function, we will require request builder of URL and m, as we want this function to work for any type of m. And for the method, we return a request builder for the other way around with u, because we want to have both type, and method. And we create and return our new request builder object. And body and headers do not need to change. We get our main and terminal back, cargo run to make sure that everything works. And now if we comment method, we get the compiler error on build, which is basically no method for the request builder of type URL, no method. And if we uncomment method setting, then we get our request back. So let's do a quick recap before doing our PhantomData. We built our states for URL and for method. Those states have data, and so it holds the values. For our new, we start with no URL and no method. That is for the new. And for the build, we require URL and method. That is for the build function. And for all of the setters method, we are more open, with the appropriate method returning the specific type only for their properties. So now for our PhantomData example, Let's say that we want to have a method called seal that once called prevents setting any properties and only allows build and clone to be called. So let's go up. In our states, we create two types for the seal state, sealed and not sealed. We're going to implement the default and the clone, and note that both of those types do not have any data. Now, in our request builder, we add another generic, nothing else for now. Then, for our new method, we're going to require not sealed, because that is our starting point. For our build method, we're just going to take S, because we want to allow build either way in this example. And now, for all of the setting methods, we want to allow them only if the seal state is not sealed. And now for URL, we will return not sealed, and we're going to do the same for method. And now we can see that we have an error on our struct, on the S type. If we mouse over, the compilers tell us that we cannot have generics not used, and we could use PhantomData. So let's go on top, and we're going to import PhantomData. Here I use core rather than std, but it aliases to the same PhantomData anyway. If we go back down, here's a trick. We're going to define our property. We're going to call it marker seal, and of type PhantomData over S. And now the generic S is used, so the structs can compile. So now let's check the implementation. Our request builder new function works because everybody implements default, and we have the generic type fully defined. Our build method works as well because it doesn't make any use of this state. Now, our URL methods breaks because the created request builder does not contain our marker seal property. And the way to do that is just by having the marker seal, and we're going to instantiate PhantomData, and now with the function return type, the compiler has all of the information needed to plug in the right types. We're going to do the same thing for method, and body and header do not create request builder, so it's not needed. By the way, let's do a little cleanup. For the URL and the method functions, the mute self is not needed because moves are not mutes. So we can remove for URL and everything works fine, and we can do the same for method. But obviously for body, the mute is required as we are muting the properties. So now let's go back on top to implement the seal function. And we're going to implement it for any URL state, any method state, but only for the not seal state. So we need to declare u and m. And now our seal function just takes self and return a new request builder type of the seal state. And in the implementation, we move all of the properties except for our marker seal, obviously, which now will map to our seal state. We bring back our main and terminal. We add seal before header. We get a compiler. And if we do our cargo run, there is no header method for the type sealed. If we move the seal after all settings, then it works. And if we move it anywhere before, it fails the next method call. So that is very cool. Now the cool thing is that plays very well with clone. So if we want to reuse the request builder, we get our last sealed request builder, we will use it the first time calling clone, and then the second time using our original one. Everything compiles, and if we do a cargo run, we get our two requests. And now if we try to set the property after the seal, we get our compiler. And that's it. That was a quick introduction to the TypeState pattern in Rust. Hopefully you liked it. Until next one, happy coding.